Okay, we're going to begin chapter 13 in this video. First thing is I've got some formulas here. These are all formulas that we're going to be talking about. Below that is an APR table and a monthly payment to repay principal and interest on a $1,000 mortgage. That's for like if you're buying a house. Okay, so we'll talk about the tables later on there. But anyway, that's there for you. Up on Blackboard. Section 13.1 is just kind of the basics about financial management. Chapter 13 is called Financial Management. So definition there, it says interest is the fee paid for the use of money. Okay. Another definition, principal, which is denoted by a capital P, is the amount of money invested or borrowed. Okay, whether that be from a bank or an individual, principal is the amount of money that you're borrowing. Okay, the rate of interest, which is denoted by a little r, is the amount charged for the use of principal for a given period of time. The interest rate is typically expressed as a percentage and is usually on a yearly basis. When doing the calculations, we're always going to write R in decimal form, okay, so keep that in mind. Simple interest, which is denoted by I, is interest calculated only on the principal. Okay, so nothing else is being figured in. From that, we got the simple interest formula. Interest equals principal times rate times time. The time is in years. Okay, and so problem 1 says that Jonathan purchased new equipment for his yard maintenance business. He borrowed $2,325 to pay for the equipment, and he agreed to pay off the loan in 9 months at 7% simple interest. Find the amount of interest that he will owe. Okay, so the interest is the principal times the rate times the time. Now the rate again is always a percentage. Okay, the rate is always in decimal form. Okay, it will be given to you as a percentage in the story problem there. The time is always in years. Okay, so 9 months is 3/4 of a year. Okay, so I go to the calculator and I can type this in here. So was it 2325 times 0.07 times 9 divided by 12, and we should get $122.06. Okay, by the way, something to know, always round to the nearest cent, okay, for the things that we're doing in this chapter. The things on financial management are going to be, always to the nearest cent. Okay, so that's how much he would pay in interest. Okay, problem 2 says that Jorge took out a 75-day loan of $3,500 at an annual interest rate of 5.5%. Find the simple interest due on the loan. Okay, so I would take 3,500 times 0.055 times 75 divided by 365. You assume not a leap year, okay? Assume that for all the calculations, unless you're told otherwise. Okay, so $39.55 is how much he would be charged in interest for getting this loan. Okay. Definition, the future value that a borrower repays for a loan, which is denoted by a capital A, is the principal plus the interest. The original principal, capital P, can be thought of as the present value. So sometimes we call it the present value. The simple interest formula, or the future value for the simple interest formula, is where you take the simple interest plus the principal. Okay. Now, using the formula given above there for simple interest, principal times rate times time, You got the principal plus the principal times rate times time. The principal's in common, so I can factor that out. And you're going to take the principal times 1 plus the rate times the time. Okay, and if I divide both sides by 1 plus the rate times the time, then the principal is given by the future value divided by 1 plus the rate times time. Okay, so let's take a look at problem 3. You deposit $2,500 into an account at 3.5% for 5 years simple interest. Find the future value. Okay, so here's the formula that we need to use. Principal times the quantity, 1 plus the rate times the time. So if I go to the calculator and type that in, 2,500 times 1 plus 0.035 times, we're going to see how much is there in 5 years. And looks like $2,937.50 is what I get. Okay. Problem 4, Paul is owed $530 by the IRS for overpayment on last year's taxes. The IRS will repay the amount at 4% simple interest. Find the amount Paul will receive if the interest is paid for 8 months. Okay, so if I go to the calculator here, the principal is 530 times 1 plus the rate is at 4%, so 0.04 times 8 months, so 8 divided by 12, and I'm getting $544.13 is how much he would receive back then. Okay, find the total amount that Paul will receive if the interest is paid for 8 months. So he's going to receive this amount back then, rather than the $530. Okay. You take out a 5% simple interest home improvement loan today, which will be repaid 10 months from now, with a payoff amount of $1,979.17. What is the amount that you're borrowing? Okay, so if I take the $1,979.17 divided by 1 plus 5% rate, so 0.05 times, we're going to see how much we get back, or see how much we're borrowing for 10 months. So T would be 10 divided by 12, and I'd hit enter. Looks like $1,900 is the amount that we're borrowing, and that's not how much we're gonna have to repay though. We're gonna have to repay $1,979.17. Okay. Next thing is a definition. Compound interest is interest earned on principal that is reinvested to earn additional interest. Okay, so it's money that you've made in interest that you're going to let sit there in the bank and gain more interest on top of that. Okay, the future value for compound interest is we take the present value times 1 plus the rate divided by the number of times compounded in a year, n to the nt power. Okay, so as an example, problem 6, Sal decides to invest $1,550 in a corporate retirement account for 10 years at 3%. Okay, at the end of 10 years, how much money will he have if the account pays interest that's compounded. Part A is semi-annually, Part B is quarterly, and Part C is monthly. Okay, so I'm going to be using the compound interest formula on each one of these. So if I take 1550 times 1 plus 0.03 divided by 2, because I'm compounding semi-annual. So semi-annual means twice in the year he's going to gain additional money on top of this. Okay, raise that to the power 2 times 10 is 20. Okay, and whoops. So to the power 20, and I'm getting $2,087.63. Okay. By the way, for this section, always round to the nearest cent. Okay, even though you'll likely be given an amount, that goes way past the decimal point there. Always give that to the nearest cent. Okay, whatever that is. So that's how much he's going to repay back. Okay, or excuse me, that's let's see. So how much money will he have? Okay, so he's going to have $2,087.63 if he invests $1,550 today. Okay, in 10 years, he's going to have that. Okay, how much will he have in the 10-year time span if the account pays interest quarterly? Okay, well, the only thing that's changing here is the n value. So if I divide by 4, and that's to the 40th power, since 4 times 10 is 40, he's going to have $2,089.94. Okay. So what if he's what if the account pays interest compounded monthly? Well, again, the only thing that changes there is the n value. So we're compounding monthly. Let's see. So you got divided by 12 to the power 12 times 10 would be 120. Okay, and I'm getting $2,091.50. Okay, and of course, the more times that you compound, the more money you'll have. Okay. In fact, problem 7, we say that interest is compounding continuously if we can make the compounding period infinitesimally small. We're going to use the formula A equals P times E to the RT power, where E is this number here. By the way, this is a very important number that you'd see a lot in like a later part of an algebra class or in calculus or something like that. Okay, to find the future value of a $1,550 deposit at 3% for 10 years if the account pays interest compounded continuously. Okay, then compare these results to what we did here in problem 6. Okay, well, so since I'm compounding continuously, I'm going to be using the PERT equation. And so I'll take 1550 times E to the power 0.3 times 10, or 0.03 times 10. And of course, make sure that you got parentheses around that entire exponent, okay, RT. And I'm getting $2,092.28, okay, is how much he'd get back. And that's going to be the most money that he'd get back there. Now, I have to be honest here. I have never ever seen a bank offer interest compounding continuously. That's just something that we don't see in the real world. Okay, so I mean, if like there's no bank that I know of that's going to give you money every second on the on the second, okay. But if it did, this would be the money that he'd get back, okay. Now, while the PERT equation is not a useful equation for investing money, it is very important for looking at how other populations grow or get smaller over time. Okay, so like, for example, if you were going to study the population of the world is something that's continuously growing. Okay, continuously is a word that I've used on purpose, continuously growing. Okay, so in that formula, for studying the population of the world, like it would make sense to be using the PERT equation. Okay, but not not when you have like a start-stop thing. Okay, it's not like in this problem where well it's not like like going back to population, you have like all of a sudden at one split second there's millions of babies born, and then there's no activity for like 3 months, and then all of a sudden at one split second there's millions of babies born. Okay, and then no activity for 3 months. It doesn't happen like that. Okay, so there's a note there. Unlike account values, under interest compounding, which makes sudden jumps at certain points in time, such as quarterly, monthly, or daily, price levels tend to fluctuate gradually over time. Therefore, it's appropriate for inflationary estimates to use the formula for continuous compounding. Okay, problem 8, it says in 2017, the price for a gallon of gas was $2.42. Find the estimated price for a gallon of gas in 2025 using Part A, a 2% inflation rate, and then Part B, a 10% inflation rate. Okay, so what if we have a 2% inflation rate? Well, $2.42 would be the p-value. And so if I type that in, 2.42 times e to the power 0.02 times, okay, if I'm going from 2017 to 2025, that'd be 8 years. Okay, so 0.02 times 8, and I'm getting $2.84 for the price for a gallon of gas over the next 8 years. Okay, and so that's not bad. Part B, okay, what if we have a 10% inflation rate? Okay, well everything else is going to stay the same except for the R value. It would be at 10% now instead of 2%. So if I hit, if I change this to a 0.10 or 0.1, same thing, then okay, the price for a gallon of gas is going to cost $5.39. And so hopefully, it doesn't cost $5.39. That'd be quite a bit of money for 1 gallon of gas. Okay, but so you can see that for a gallon of gas, it at least makes sense to be using this formula. That's the PERT equation, because the price for a gallon of gas gradually changes. I mean, one day it's $2.42. Another day it's $2.44, another day it's $2.38, or whatever. Okay, it's like a gradual change. It's not like one day it's $2.42, and then the next day it's $7.11, and then on the next day it's only 15 cents, and then I mean, if it were that drastic, then we would use a different formula. Okay. So the homework here in this section is on page 742. So be sure to look at the problems there when you get a chance in section 13.1. Okay.